Hello everyone. Today we're gonna solve the remove duplicate from a sorted array. So let me summarize the input first. So we will have an array numbers which is already sorted in non-decreasingly order, and we have to return this the order of we need to return all of the element like distinct element in the array, and we have to keep the order remain the same relatively. So, for example, if we have this array, we will remove one right here, and we will keep one and two. And for the last element, we don't care about the last element, but we need to keep the array with the same size. And this problem asks us to do it like in place, which means that we don't use any additional array, right? So if we see this question in the interview setting, we should have some kind of question to ask the interviewer. For example, we can ask like, do we have any floating point? And you can ask like, is the array totally random or is sorted? Just to confirm with the interviewer. And you can ask like, how large is the value. So usually people will tell you that, yeah, this number you can just use integer to store all of the numbers, but you should ask them so that they know that you are aware about the situation. So for example, if we have this one, we need to remove uh, the duplicate value 0, 1, 2, 3, and 4. And the last, we don't care about the last. So what we do in this problem is that we will use two-pointer approach, which means that one pointer would be for the position for the new value, and the order would be for our current position. So let me illustrate it. I will call the first one would be the fast pointer, and the second one would be the slow pointer. And we will consider all of the fast pointer to see if this position is already duplicated. For example, we will consider if the nums of f would be equal to the nums of f minus 1, because we already know that the order is sorted. So if we have this condition, which means that the current numbers is already duplicated, and we already stored at the beginning, so we will skip that one. For example, if we look through this position, we will know that this number is duplicated, right? So if this condition is satisfied, which means that the number of fast pointer is duplicated, right? And else we will store the numbers f to the number slow, which means that we will assign the value of the fast pointer for the slow pointer. right? So let me illustrate how it works. So let's say we will look the fast pointer from 0. We will consider this condition. We have, yeah, let's start from the second one. We saw that we can see that the number of 1 will be equal to the number of 0, so we will skip this one. And for the second index, we saw that the number second is different with the number 1, so which means that we will store this number to this position, right? So we will increase the slope pointer, and we will assign the value of the fast pointer to the slow pointer, right? Which means that we will assign 1 right here, and then we look to this. To this, we see all these are duplicated, and then we look to this, and we see that this value increase the slow pointer, and we will store the value of the fast pointer to the slow pointer, and continue. We see that it's duplicated, and right here we see that 3 different with 2, so we increase the slow pointer, assign it to 3, and this is duplicated and this is not, so we increase the slow pointer and assign the slow pointer by the fast pointer value. Yeah, that's the process. And now how can we do it? So first of all, we will have a slow pointer would be equal to 0, and then we look through the fast pointer will be equal to 1, and the fast pointer less than the size of the array. And then we will consider if number of fast pointer is different with the number of fast pointer minus 1, which means that we don't have duplicated, right? Let's say we have duplicated, we will do nothing right here. And then if we don't have duplicated, we will increase the slow pointer first, and then we will assign the value of the slow pointer by the value of the fast pointer. Yep. And then finally we will return the size of the new array, which means that we will return the slow pointer plus 1. And the time complexity for this one is O(n), and the space complexity would be O constant. With n is the number of elements in the number arrays. Yeah, let's see if we can pass all the test cases. Great, we already passed all the test cases, so hope this helped you guys.